Welcome to aminacademy.com and complex analysis regarding dot and cross product of complex numbers. Let us do some solving problem in geometry. Prove that the area of a parallelogram having sides z1 and z2 is modulus of z1 cross product of z2. So we had to prove cross product of two complex number with modulus is represented by area of parallelogram of that forming with that complex number. Here, look at this figure. Here, let this complex number represent z1. This is z2. This is the altitude, that is h, which is represented by modulus of z1 sine theta. Now, area of parallelogram having sides z1 and z2. Here, this complex numbers vectors z1 and z2 having its sides. Now, we know that this area is equal base into height. Base is modulus of z2 and height is modulus of z1 sine theta is equal to modulus of z1 modulus of z2 sine theta, which is further represented by cross product of modulus of cross product of z1 and z2. This is the area of the parallelogram. Now, one more question. Find the area of a triangle with vertices at A is x1, y1, B is x2, y2, C is x3, y3. Let it be, this vector is z1, this vector is z2. Now, the vertices of C2A is the vectors from C2A is Z1, which is represented by x1 minus x2, x1 minus x3 here, x1 minus x3 and plus I vector y1 minus y3, and z2 represented this is C to B, which is denoted by x2 minus x3 plus I vector y2 minus y3. Since the area of the triangle with sides z1 and z2 is the half the area of the corresponding parallelogram. Therefore, area of triangle is half of area of corresponding parallelogram. Therefore, which is equal half of modulus of Z1 cross Z2, which is equal half of the imaginary part of x1 minus x1 minus x3 plus I vector I of y1 minus y3. Into x2 minus x3 x2 minus x3 plus I of y2 minus y3. Further, which is equal imaginary part is equal after multiplying and simplifying, this minus not plus, minus so after simplifying we get x1 y1 minus y1 x2 plus x2 y3 minus y2 x3 plus x3 y1 minus y3 x1. We can write this expression in terms of determinant form, which is equal x1 y1 1 x2 y2 1 x3 y3 1. This is the area of the triangle. Therefore, so far we have done is area of the parallelogram is modulus of the cross product of two complex number Z1 and Z2. That is modulus of Z1 cross Z2. Similarly, we can get area of the triangle with vertices, given vertices is half the modulus of Z1 cross Z2, which is represented in determinant form like half of x1 y1 1 x2 y2 1 x3 y3 1. We have done. Please subscribe our YouTube channel.